Hello, I'm Roman, and welcome back to the series of the videos Neural Networks from Scratch in Go, where we using this book called Neural Networks from Scratch in Python, but we write in everything with the Golang. And I'm still continue with the model object. As I told before, probably it will be, I will spend the most time implementing the model object because it requires to do a lot of the changes. And right now I am somewhere here, and I have, in addition to the stuff that I need to do from the book, I have the list of the things that I need to finish. One of the things, so right now we have model. We have the model class. I have some to-dos, so we can take a look. This is additional things that I need to double check and probably fix. This one I'm not going to implement. So yeah, this one this one should work only on not on the one hot encoded array, but rather on the column vector where every row will contain only one element with the target class for the categorical cross-entropy loss. So today right now I'm trying to kind of build in my head what are the things I need to finish. I think right now we have the train methods, and if we take a look, fix target pass. I can try to use it in the main, because right now we have the sign data, and we could run the model training, and hopefully it won't crash. I'm not sure it will produce the proper result, but well, it will be good if it will even not crash. So let's try clear and make run. Yeah, it's crashing. So at which place? Command dense layer, 0 lands in the matrix dimension. Model 91. Model 91. Okay, so there is a problem with the backward methods. Yeah, backwards. Train, dense layer, met dense, new dense. So that's the issue with the creation. And where do I create it? Model 91. This one? Okay, then we should debug, right? We have the main, we close this, we run the debug, and let's see. Okay, it returns the inputs. But yeah, it's actually where it was. It was the dense layer 88. Wait. Dense layer 88. Okay, so for some reasons I'm passing an empty. I'm passing the empty one. So this is interesting. Okay, so okay. All right, so that's the problem. In the first place, actually, okay, 0. All right. So where it was, I think here. But it should feed this one, right? Okay. We should take the D inputs. Okay, let's take a look. Yes, it should be the D inputs. Self-perform backwards with think which one is model. Train backwards from the model. No expand action for current line. Oh, I guess. Okay. So we have the 5, right? So we can go inside. No, we're going inside. That's for the loss. All right. Then we going inside, and what I can see here. Where am I? There is a backwards. Okay. So the D inputs is actually it's nothing. Okay. What's happening? Okay. And how I can inspect it? D inputs empty. So wait. Okay. So for some reasons, it's not creating. Right. Because this one main can I no send the main goal? Maybe can I do this? Okay. What we have inside model, we have the layers, and we have the last one is the linear activation. Okay. Oh, wait. So we have the linear activation, but do loss has the D values actually? No. Loss backwards from output. Wait. Okay, wait. So I have the loss, right? Wait. We form the backward path for the model, right? Where is the whole code? Close of the loss. Output. Where's the backwards? Passing the inputs as the parameter. Okay. Okay. Loss backwards. Okay. Oh. Wait, but mean squared error. Okay, so we have the D inputs. We have the loss, the base loss, we have the D in. I don't get it. Wait, I don't understand. Loss the inputs equals to k 1. How it can be possible? Wait. Print one mat loss the. Okay, so there are some values, right? But different that I will d values. Okay. Choose. Mm, poof, 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 poof. Mm, backwards. Math. What I want to print? Loss the inputs. Okay, so the d inputs for some reasons is empty. But okay, what loss I'm using? Main, what's a loss function that we have? Mean error squared loss, right? Mm. Is squared error loss. So the problem that it it stores the inputs, but in the backwards methods of the model, it tells me that it's 0. So, okay, so maybe that's the thing that I've been actually thinking, that it should be, it should be the reference here. But if I will try to make, yes, now means code doesn't implement loss interface. Backward has pointer receiver. And this is what I don't understand, how I can... I cannot do this. Because if I cannot do this with... well, for sure, I don't know the goal to know the thing, but... how I can... what I can do? Can I do this? Yeah, it introduces... no, cannot... the pointer to interface, not interface. Okay. Okay, I'm going to use Google. So as an argument model set. Wait, cannot use loss as a loss interface value. Doesn't implement loss interface. Okay, this is my problem. Okay, let's use Google, because I have no idea what to do this. I have this example. Okay, there is an interface, there is the implementation. With this one, it's a field. Okay, because it's a series, not a pointer time. Your pointer to struct should implement the interface. In that way, you can modify its fields. Look at how I modified your code to make it working as expected. And maybe... oh, okay, so that should be this, and that should be this, right? But it tells me about backward methods. Mean squared error loss. Mean squared error loss. White complains specifically about the backward methods. However, pointer to struct will implement the interface and change the new create method to return and get this work. Main. Oh, okay. Okay, so now I need to check those mean. Okay. Let's go to the model, I think, once again. Wait, Why that's me sudo every time? Okay, so the problem was that I was the object incorrectly, and that was the issue, not in the interface. Okay, I can live with this one. Finding files. I want to remove all of the usages of. No, I want to use grep mat for methods. Okay, I'm moving this one. Mat for. No. Mat for methods. Ah. Yeah, I'm still confusing the shortcuts sometimes. I want to have this. I want to remove this and this. Why? So still prints me something. Okay, formatted. Coral. Oh, this one. Okay. Backwards. That should be backwards. This one, removing. And I think that's compare. Compare. In some place I have printing of the results. Print scatter data regression. It's in the models, categorical models. No, epoch, optimizer, loss function name. That's description. Oh, it's actually in the train method. I'm printing something else. Oh. Wait, why it returns? Wait, we return in the prediction, then we okay. Comparison and accuracy is actually accuracy, calculate accuracy. Wait. Oh, I don't need this. I need wait. I have accuracy. Then I need predictions and target and y. Cannot use y. Yes. Yeah, I mean, this is what I will need to fix for now. Let's just do the same trick. Oh no. Wait, why I cannot? Yes. Well, that's correct. So what we have now? Okay. This looks surprisingly good. I mean, I had the same. I mean, if you take a look at the accuracy, you can see that sometimes it drops down. And I had the same. Most likely it's what's this overfitting. Well, not the overfitting, maybe the model is too big. And we have the zero regularization loss because I don't actually configure it. And what was the result here? Accuracy 97, loss 0. I mean, okay, so what I wrote so far works fine for the specified example. By the way, how I can println, do I have the println f println? Printer formats using the default formats for its operand and writes to standard output. Spaces are always added between operands. And a new line is appended. It returns the number of the bytes written. And so you tell me that I don't have to do this thing with the spaces, right? Alright. Let me test it. This and this one. Okay. The only thing I would like to change is... Oh, you know what I will do? I will do this. No. Oh, it's training. Okay. All right. And I mean, okay. Let it be just with the space and accuracy, learning rate. So I have this very small loss. It comes near the 0. I have, well, the small learning rate decreasing because of the decay, accuracy is increasing, and it jumps sometime because maybe the model is too much. And one thing I actually can add the L2 regularization like we had before. So, for example, I will go into, well, main, this one, right? So basically that should be my binary model, right? Or is it the regression model? Wait, no, it's a regression model. So that should be this one, right? What I can do, I can do this, and I can do this, and this, right? And that was the previous one. We actually didn't have the L2 for this one, right? And I mean, I still need to do all of the things in the model, but I can do this. Wait, we want to add new stuff. Okay. Then I don't need all of this, and that should work. Wow. Integral percentage loss, softmax classifier. Interesting that it started to compile it. Has no, wait, softmax loss 25. Softmax loss 25. return that will be actually calculate loss of the of this one. Inputs y y this. Yeah, but interesting why it started to be compiled. Yeah, that's one of the things that I need to fix. Okay, let's just do panic for now, and to do fix, and we'll comment panic. Okay, fix. Let's do it like this. Loss function models binary. Okay, it started to compile the things. I will need. Okay. Visual inside this square. Then what I need to do, I can substitute the beginning of the line with the comment, right? And then J, that should do the trick, right? And I think, okay, the categorical works fine. Well, it compiles fine, but yeah, as it was before, I need to do some things. Our new model is behaving well, and now we'll be able to make new models more easily with our model class. We have to continue to modify these classes to handle for the entire new models. For example, we haven't yet handled for the binary logistics regression. For this, we need to add two things. First, we need to calculate the categorical accuracy. Okay, let's do the categorical accuracy. Where is the accuracy? We have the accuracy. And we have the categorical. How it looks like. Regression accuracy. Okay, that will be what it will be. Type categorical accuracy. Struct. And we will have two things. Well, okay, this one we change for categorical accuracy here, right? I'm not sure we need the precision. This one is removed, and again delete inside this one. We don't need this. Compare. Okay, so yeah, that's interesting. Okay, so that should be this one. Binary is binary model bool, right? And so there should be a struct. Well, we can define it once we. Okay. So what do? If len y.shape equals to compares prediction to the ground truth values. So the comparer of the predictions and the target. And that will be the interesting part. This is the same as the accuracy calculation for classification, just swapped into class with additional switch parameter. The switch disables one hot to spiral label conversion, while this class is used with the binary cross entropy model, since the model always required the ground truth values to be a two-dimensional array and they are not one hot encoded. Note that we don't perform any initialization here, but the method needs to exist since it's going to be called from the train method from the model. The next thing that we need to add is the ability to validate the model using the validation data. Validation requires only a forward pass and calculation of the loss. The data loss will modify the calculate methods of the loss class to let it calculate the validation loss as well. If not, if just data loss, return it. Okay, I won't need to do this because my calculate function returns only the data loss, and I have a spare function, well, additional function to calculate the regularization loss. But I'm checking the recording time, and I think I will continue next time. I think that's enough for me today. I will need to remember how it was done for the categorical entropy loss. I mean, I remember this thing, but I just now need to do it with a fresh mind and a fresh start. So I will start doing it tomorrow. Yeah, that's it for today. As usual, less progress is better than zero progress. And what I'm doing here is trying to be consistent and publish every day and work on this every day. So far, I passed how long? Almost 500 pages from 666. So I definitely around 3/4 of the book, which is, I mean, it's cool. I mean, you can do anything with the consistency. And this is one of the reasons I'm doing this. Not just, not just to tell it with words, but actually showcase that it's, well, you can do this. So yeah, we'll see you tomorrow. Thank you for watching, and I see you tomorrow. Bye-bye.